Okay, so we are going to blast through section 2.3, which is on differentiation formulas. We're not going to prove any of these. Many of you have had some calculus exposure in your past, and so we're going to just recap what these rules are, and hopefully this video will be tremendously short. Okay, so rule number 1 is for constants. So C is a constant. Okay, this means then its derivative is equal to 0. Okay. Geometrically, what you're thinking is that if c is a constant, then the graph of this function, which is f of x equals c, so no matter what input you give, the output is c, this has slope 0. Okay, so that c is a constant. 2, if we take a look at the derivative of the function x, this is just equal to 1. Okay? Again, this is a line. This function gives us a line of slope 1. This is f of x equals x. This x, the slope is 1. It's 1. More generally, this is just a specific case of a very general rule, which is that if you have any positive integer, so if n is a positive integer, as a positive integer, then the derivative of the function x raised to the n power is gotten by what is likely a familiar rule to this. So for example, if f of x is x to the 8th power, then the derivative of f of x is 8 times x to the 7. And you know, if we wanted to take more derivatives, let's say we took the second derivative of this, well, let's come back to that. So that's so that is a rule that we have. In fact, let's get to this right now. So this is rule number 4. If c is a constant, then the derivative of any function multiplied by that constant is equal to c times the derivative of the function. Okay, so constants, when they're being multiplied by functions, just as we say, come along for the ride. You just, c comes along for the ride, and you just take the derivative of your function f. So now we could actually fill this in. If f of x was x to the 8 from the last example, then our second derivative of f, which was just the derivative of 8x to the 7, is, well, 8 comes along for the ride, and then we just take the derivative of x to the 7, so that is x to the 6. So if my arithmetic is correct, 8 times 7 is 56. So this would be the second derivative of that function. All right. What rule was that, number 4? I don't care what you label these rules. All that's important to me is that you know what they are. So the derivative of two functions being added to each other or subtracted from each other is equal to the derivative of the first function added to or subtracted from added to the derivative of the second function, or with the second function subtracted. So for example, if we had 8x to the 4 minus x cubed, and we wanted to take the derivative of this, then we would take the derivative of 8x to the 4 and subtract the derivative of x cubed. So that would be 32x cubed. That's bringing the 4 down. Product of 8 and 4 is 32, subtracting 1 from that power 4, and then subtract 3x squared. Okay, that is the sum and difference rule. The next rule we have is called the product rule. So this says that the derivative of the product of two functions is equal to the following expression. We take the derivative of the first function, multiply by the second function, and then we add to it the first function left by itself times the derivative of the second function. Okay, so we get, excuse me, so we get this rule. An example of this, the derivative of, let's say, x squared times 1 plus 2x minus x to the fourth. Okay. This is a product of two functions here, f. You could take f to be x squared and g to be the function 1 plus 2x minus x to the fourth. And then we just apply the rule. So this is the derivative of x squared times the function 1 plus 2x minus x to the 4 plus the function x squared left alone times the derivative of 1 plus 2x minus x to the 4. Okay. Continuing along here, the derivative of x squared is 2x. Okay, so this piece there becomes that. And then if we leave x squared alone and we take the derivative of this, the derivative of that constant is 0. The derivative of this is the 2 times the derivative of x, which is 2 times 1. And then here we have 4x cubed. Okay, now I'm not going to ask you to simplify in general the derivatives. Usually I would just have you leave this answer as this. Good enough. Unless you need to simplify, don't whenever you're taking derivatives. So I'll be clear about that on exams and quizzes. All right, the next rule, where were we? The last one was Rule 6. Rule 7 is called the quotient rule, and so if you probably know what this is going to be a rule about, that is the following. If you take a quotient of two functions, then this derivative is computed by the following formula. You take the derivative of the top function times the bottom function left by itself minus, now you leave the top function alone, times the derivative of the denominator function, and then you divide all of this by the denominator squared. Okay, now this is another example where we have to be very careful. So we're taking, let's say our functions are x cubed plus 2x over, let's make it simple, x squared plus 1. Okay, so if this is our function and we're interested in taking the derivative, then this numerator function is playing the role of f, this denominator function is playing the role of g, and so we very simply, we just 3x squared plus 2, that's the derivative of the top function, times the bottom function left by itself, is that, then leave the top function alone, x cubed plus 2x. Be very careful with your parentheses here, times the derivative of the denominator function, which is 2x, and then we divide by x squared plus 1 squared. And I would not ask you to simplify something like this in general. I mean, certainly we could simplify this if we wanted to, but I won't ask you in general to to simplify unless it's absolutely necessary. All right. If n is a positive integer, then the derivative of x to the minus n power is gotten exactly the same way as with the previous rule for powers. You just bring this power down and then you subtract 1 from that power. Okay, let's see how this works. So for example, 1 over x squared. Okay, this is equal to x to the minus 2. So we're in the situation where we have x to a minus power, and the power is a positive integer. So here n is 2 in this. So if that's the case, then we can take the derivative of this. just by taking the derivative of x to the minus 2, which is, according to our rule, bring the power down. And then minus 2 minus 1 is minus 3. Okay, and so if you'd like to simplify this, you could. X to the minus 3 is x cubed. So this is the example there. Okay. So I will expect you to be able to recognize that a positive power of x in the denominator is a negative power of x in the numerator, and to be able to apply this rule whenever you can. More generally, where were we? 8, 9. If if n is any real number, then the derivative of x to the n follows the same rule. You take the power, it appears in the front as so, and then you subtract 1 from the power. So this is really the rule for no matter what exponent is up there. So what do we get by example here? How about the square root of x? Okay. The derivative of the square root of x is the derivative of x to the 1/2 power. And so we take 1/2, bring it out front, times x to the minus 1/2. That is 1/2 minus 1 is minus 1/2. And if you'd like, this is x to the minus 1/2 power. So this is a square root of x in the denominator. Okay, I expect you to be able to follow this kind of simplification very easily. So really understand this manipulation. Understand how we got this. And if you don't, then please come and see me. All right. So let's just do a very quick example here. So how we would use using these formulas. Okay, so this is an example of using. So let's find the equation of the tangent line to y is equal to the square root of x divided by 1 plus x squared at the point 1/1/2. Okay. So this is an approximate graph of what this function looks like. Something like that. This is f of x equals the square root of x over 1 plus x squared. Here's the point 1, and so we want to find the equation of this line. The equation of that line. That's what this is asking us for. We have y equals this function, so its graph looks like that. The point 1/1/2 is illustrated right there on the graph, and we're just looking for the equation at that point. So this is a fundamental question using derivative formulas. So the solution to this is gotten by, well, we need to know what the slope of this line is. The slope is related to the derivative. So the slope is equal to f prime of 1. Okay? This is taking the function, taking its derivative, and plugging in the point 1. This will always be true. This is absolutely fundamental. You should know this like the back of your hand in order to do these kinds of questions, and you will have to do these kinds of questions on a regular basis. So we have to compute the derivative of f. So this is the derivative. It's the derivative of the square root of x over 1 plus x squared. This is a quotient, and so we must use the quotient rule. So we take the derivative of the top times the bottom minus, leave the top alone, times the derivative of the bottom all of this divided by the denominator squared. This was the quotient rule. Okay, so notice what we did. I have not done any calculations here whatsoever. All I've indicated is what the rule says about how you should take derivatives. I really strongly encourage you to do this first step always because it will make your life much easier. This is x to the 1/2, so that is 1/2 x to the minus 1/2 when we take its derivative times 1 plus x squared minus, and then we're taking the derivative of that. Well, the 1 will go away and this x squared will become 2 times x. So we get the square root of x times 2x divided by 1 plus x squared squared. Okay? Maybe we would take one more simplifying step and write this as 1 over 2 the square root of x times 1 plus x squared minus the square root of x times 2x. All of this divided by 1 plus x squared. Okay. Now we can plug in 1. Okay. This is our derivative of f, and now we plug in 1. So f prime of 1 is equal to, okay, so we have to do a little bit of arithmetic here. There's a 1/2. And square root of 1 is 1. Here, 1 plus 1 squared is 2, so that is 2. And then we have the square root of 1 is 1, 2 times 1 is 2, so we get 2. And then when we put a 1 in for x squared here, we get 1 plus 1 is 2, squared is 4. And so the slope of this, so there's a half times 2, that's 1. 1 minus 2 is minus 1, and so we get minus 1/4. So this is the slope. Okay? The slope of this line is minus 1/4. Now we just need to find the equation of the line. Well, we need, in order to find the equation of the line, we need a slope, and we need a point that it passes through. The point that it passes through is 1/1/2. I don't know if you guys can see my cat coming through here. Hey, Sylvester. All right, buddy. What the hell? Okay. All right. Okay, so back where we were, that wasn't Sylvester destroying my camera, it just somehow ran out of batteries right at that moment. So the battery's a little bit more charged up now, and we're going to try to get through this last little thing. So this was finding the equation of the tangent line, and we just determined that the slope there is minus 1/4. So we need the slope to find a line, and we need a point, and that's the point. Okay, so 1, 2. So really easy, just to finish this up, we have slope is minus 1/4. The point is 1/1/2. So the line is y minus the y coordinate divided by x minus the x coordinate equals minus 1/4. Equivalently, I guess we get y minus 1/2 is equal to minus 1/4 times x minus 1. Or y is equal to 1/4 x, minus 1/4 x, and then that's 1/4, and then we're going to add 1/2 to it, so we're going to get 3/4. So this is the answer to that question. All right. Okay, one more example. Let's find all the points on the hyperbola x times y equals 12, where the tangent line is parallel to the line y, let's see, how about 3x plus y equals 0. Okay. So this is a little bit obscure of sounding of a question. Just for our facts, this is what this hyperbola will look like. Looks something like this, like that. Okay, this is the hyperbola. We know it as one of the conic sections, the hyperbola. Let's rewrite this as y equals 12 over x. Okay, that's x times y equals 12, so y is equal to 12 over x. This is what the graph of this looks like, approximately. Okay, so really what we're asking ourselves is, well, what is the equation of this line? Y is equal to minus 3x. So this is a slope of minus 3. This is a line, this line here is this. This is a line of slope minus 3. So we're asking ourselves, where on this graph is the slope equal to minus 3? Okay, so we're probably looking at points around here and maybe around here, or something like that. These are just, I mean, these are just informal. This is our informal guess, okay? There are probably going to be 2 points on the graph of this function where the slope is equal to minus 3, and that's all we're asking for. So find all the points on the hyperbola where the tangent line is parallel to this line. For 2 lines to be parallel, so here's y equals minus 3x. 2 lines to be parallel means they have the same slope. Okay, so we want to find, we're looking to find these 2. Okay, find the points. Okay, so while we know how slope relates to a function, it's the derivative, right? It's related to the derivative. So the solution to this is first take the derivative. So one of our other notations for this is dy dx. So this is taking the derivative of that function here. So the derivative is the derivative of this. Remember, this is an x to the minus 1, and so our derivative then will be minus 12 over x squared. Okay, that's if you take the derivative of 12 times x to the minus 1, its derivative is equal to minus 12x to the minus 2, right? So that's the calculation that we did to get from here to here. Okay, minus 12x squared. Okay, now we are interested in the location of when this the points on the graph of this hyperbola where the slope is equal to minus 3. So when this is equal to minus 3. So set. So that was first, we took the derivative. Second, set the derivative equal to minus 3. Okay, so if we do that, we get minus 12 over x squared is equal to minus 3. Okay, now we just have to figure out what that means for x. So we get, let's see, if we divide the 3 over, we get 4 on this side, and we multiply the x squared over, we get x squared on this side. So this right here is equivalent to x squared being 4, which of course means that x is equal to plus or minus 2. Okay. Now where do these locations go on the graph? When x is equal to plus 2, we have y, we plug in x equals 2 here, we get 12 divided by 2, we get 6. Okay. And when x is equal to minus 2, plug again minus 2 in here, we get minus 6. Okay, so these are the 2 points on the graph. And you can sort of see this, okay, based on our preliminary guessing, just looking at the graph. Okay, 2, 6, something like that, and minus 2, minus 6, something like that. Okay, so this is the answer to this question. Go back through this and make sure you understand it, because we'll definitely be doing questions like this in class. Okay, that's the end of section 2.3.